Welcome back to Ox Tools. I'm Tom. So this is part 2 of the Leitz optical dividing head instrument necropsy. So we're disassembling this thing. It got submerged in water at some point, and a restoration is pretty unrealistic for this unless you have unlimited money and unlimited time. And then what are you going to use it for in the end? It has kind of limited application. Some folks asked about what it's good for, and it's really an inspection tool for inspecting gears, sprockets, things like that with circular divisions on them. So you would use a microscope and then index them, and then check the quality of the indexing on the actual machine part. I think there was an optional bench that these came with that mounted to, and a tailstock and some other stuff. In fact, a viewer sent me a picture of his. He has one that's set up that way, so kind of cool. And you'll notice I pronounced Leitz better this time. All our German viewers were quick to jump on the bandwagon and correct me on that. So that's fine, no problem. So let's continue on with our bosonic activities out there and get the rest of this thing taken apart and see what the innards look like. It's pretty cool.
Okay, so we've got some, so these are kind of interesting here. What I think this is, and we're going to try it here, is this this plate here is held on with some dowel pins. Actually, those are threaded. You know what? I need to look at this a little closer. But they're kind of a weird nut. This one I cracked loose here. It's a weird nut, but it's threaded down the center. So what I think, my belief is that you put a screw in from the top, and you use that to help, no, that doesn't make any sense. To push it off? No, that doesn't make any sense at all, Mr. Wizard. That's backwards. You know what? That doesn't, forget it. Forget I said that. Now this one here, okay. It's tighter. So something's mounted on the inside there. So yeah, I put a little liquid love on there, and that is making the sound that it's solid. Okay, so this whole thing moves, right? Let's see. Double check that. I think this whole mess turns here with the with that axis. You know what? What the heck's going on here? The reason it sounds so solid is it's part of the casting. I don't see a seam in there. Okay, I gotta eyeball this a little bit and see what's going on. All right, this thing's pretty cool here. It's worth showing here. So what we got going on here, this is kind of neat. I noticed these two screws here, so I said, oh wait, something's attached on the inside. And what's attached on the inside is this bracket right here. But this is separate from that. And what this little chingadera is here is basically this tube holds some optics, and you can see a lens element or a prism there in the end. But when they're calibrating this thing, this tube is cantilevered from the opposite side, right? So they have to basically align the end of that tube and push it around, right? And So what they've done here is this little screw here, in fact I'll deflect it, you can see it. Watch the tube move, see that? Okay, and then these, and it's very hard to see, let's see if I can shine a light in there and you can see it. There's a little pointed element right there. Okay, yeah, you can see it there. And these screws will push it one way or the other, right? So this way, and this way, right? So they can control the attitude or the alignment of that the end of that tube. Now, to remove this plate here, I really need to back these adjustments off here so I don't destroy them. And it took a little bit to get it free. And I rubbed the fingerprints off my fingers on these knurls here, doing it, okay? And then we'll just get that. So now those little points are retracted up here, and then this drive screw is retracted now. So we'll pull this this cover element off here, and now it actually makes more sense how the thing goes together. So which is kind of cool. So let's. I got to use a slide hammer to get this to move because there's a lot of corrosion in there. So there's some kind of animalistic activities coming up here. Well, this is starting to get good here. My slide hammer didn't work. It's moving a little bit, but I suspect there's some dowel pins locating this to that that are giving me some trouble here. So wood job wouldn't be perfect without a tool to take something apart. So what I'm making here is a puller. Is a puller to help remove that. And oops. Let's tap that here a second. Alrighty, and then let me get set up here, and then we're going to give it a try here. So this is the spot that's been stubborn down here. This is the bottom where there was a lot of corrosion. There it goes. It's coming now. Yep. Okay. Come on, buddy. There it goes. All right. Look at that. Nice. So, you know how much fun you're having. It's proportional to, directly proportional to how many tools you have out of your toolbox. So the more fun you're having, so there's that tube that I was showing you earlier. You know, so it fits in there loose, but they got to secure the end. So, but you can see all the corrosion here, and it looks like there was indeed a pesky dowel pin that was giving me some trouble down there. So, and then this guy here, let's see if I can pluck that out of there for you. This is the clamping ring here that clamps around and locks the rotation. So that's a nice little piece there, and they just feed it into that slot like so, right? That's pretty slick design there. It's kind of like a snap ring, you know. Okay, well we're into the meat now. All right, so there's the guts of this thing. Let's see if I can turn this. Oh, did I put the brake on? Oh yeah, I put the brake on, Mr. Wizard. Well, oh, okay, the worm's engaged. That's why I can't turn it. So there's the spindle, and this is the graduated or the optical disc that this assembly looks at here. I'm just going to drop this in so you get some idea of what So when this thing's in here, let's see, get this dowel pins lined up, there we go. So light comes through the disc and is looking at markings on this disc on both sides of it. So that's how that setup works there. And as you see, it's in pretty bad shape there. Let me pull this out here again. And see there's the deal. It's looking at both sides of the disc. And I don't know if you can see it, but the holes that it's looking through are pretty small. So there's little prisms down in the bottom of this that light comes through, and then the prism picks up the image and brings it back up to the eyepiece. So pretty gnarly. I think we're ready to really go after this spindle thing here, but it looks like it all comes out the big end here, but we got to clear away some of this brake mechanism. So I think we're going to flip it over and work on the opposite side and take the knobs off and that cover plate off, and then we can work on getting the spindle out of there. I think we're going to go after this, our cute knob here. See if we can get that out of there. Let's see, that's 3. We're off to a good start there. It's kind of clever how they did that spring there. This is one of the fun things about this kind of stuff here. That screws pretty tight. Is studying the design elements of how some of this stuff's put together. As a mechanical designer myself, there's so much to be learned from what's already been done, and that you can just reuse and repackage for your own sinister uses. So basically they got a flat spring there that's attached with a small screw into a step, but that's what's providing the reset force for that, and it's just nice and smooth and feels pretty good, and it's very simple. It doesn't require a torsion spring or anything weird that takes up a lot of space. It's a very compact design. So there's a better shot of that. So there's the spring right there. Let's see if we can pop that off real. Oh, that's screwed up. A lot of these screws they're kind of an odd size. For the diameter to screw the slit size is kind of weird. So there's the spring I was harping about there. Yeah, pretty simple setup there. Okay, all right, let's see what's next here. This is always cool. You get to try out. These are I haven't used these yet. These are metric drive pin punches made by PB Swiss, which is clearly a Swiss company. It looks right. Right one? Yeah, okay. So look at these things. It's got a rubber grip, drive spot, anti-roll little feature, just pretty sweet. So what we got is it looks like a taper pin holding this on. Is it tapered? Oh no, I think it's just a straight pin. Now hopefully this will just come right off. No, of course not. Alright, well, I'll have to sort that out. So everything's loose here, but not cooperating, of course. Maybe we can, okay, that's maybe how we do that. Okay, that's working. bushing bearing, sleeve bearing, collar, another collar. Okay, look at that. Oh, left-hand threads, huh? There's the knob, the super knob. That's pretty cool. Okay. Okay. All right, I'm just gonna bet that this thing is just clamped in here. It's pretty typical for this kind of a thing. Oh, is there one on the bottom? Come on. Okay. Yep. Yeah. I think they're in little divots too. All right, I gotta get at this. There's one at the bottom I gotta get at, so I need a little shorty screwdriver like that or something. I want to pull this. That's that optical tube assembly. I want to just pull that out of there. Then we're going to remove this this cover plate here. We've got a few of these here where they've kind of puttied over the top. Okay. Okay. Oh, okay, a spanner. Wow, that's interesting. I wonder if those are... All right, well, let's get that off. It's got a, it's got a thread to hold down the middle. I wonder what that's for. All right, well, let's see if we can get this this hand wheel off. I need to get access up here, so I think I got to work on this a little bit. Those are some fine threads in that. Interesting. Let's see if that's... I think we got to give that a little love tap there. Moving relative to that. Let's do this. Maybe it's okay. And still turning relative to that. Let's see if I can dink that around. I think that moved. Relative to the shaft is what I'm looking at there. Yeah. Just needed a little inertia there. Okay, second lock ring. Now what? Geez, yet another one. Look at that. But this one looks like it's got pressure screws here to, let's see, where's that itty bitty little screwdriver? Of course that doesn't fit. This thing's got a lot of different sizes on it. So I think what these are, These are to do the final tightening of this so that it doesn't disturb the rotational position. Oops, excuse me. Yeah. Looks like they went into some little divots there. Yeah. Interesting. Okay. Alrighty then. Are we getting any closer? Oh yeah. Something's moving here. Something's moving finally. Okay, so what I think needs to happen next is this worm here, this real fine adjust here that does this, right, needs to come out. It needs to back out of this to disengage this so that it can come off. Whew, interesting. Cone point set screw. I can't get at that one. There's one back in there. Oh. Okay, I guess I don't need that one. Oh, that's interesting. Look at that little deal there. Oh wow, that's a pivot. Cool. Oh, okay, so, all right, there's our set screw, right? Huh, what's going on there? Why does it have that? Oh, you know what? You know what I bet's going on? I bet you this is an adjustment screw that pushes against, let's see here. Oh yeah, so there's a little bushing in that. So what they can do is they can take the backlash out of the worm, right? So it's pivoting here, and then this screw pushes on that bushing and pushes this into engagement with the worm gear. So this is the worm screw and this is the worm gear. So they can push it into engagement and take out all the backlash, or take out whatever backlash they want to take out. So that's why that's pivoting. Actually, that's a good rotary table design right there too. So you know, if you want to build your own rotary table, this is actually a good provision to be able to disengage the worm and then put it back in and take out all the backlash basically in the hand wheel. So if you're going to build a little rotary table, that would be the way to do that. So, okay. So now, yep, okay, so this is coming out now. There should be a nice worm wheel there. And in fact, if this wanted to get repurposed into a small little rotary table there, you got basically all the ingredients right there. I'd have to count the teeth and see what it is, but my guess is it's adequate for that kind of a thing. And we got some little preloading springs here so that it has the right feel, the right amount of drag on the hand wheel. I think it's got some weight to it too. Pretty cool. All right, nicely done. All right, let me look at this next bit here. So I think we've found our first actual ball bearing here, and what this is a thrust bearing here. So when this whole hand wheel assembly is tightened up, it's preloaded against this against the thrust bearing here. So we're gonna take a look at that. Yeah, crack these loose here. Okay, so that's loose. So let's lift this bearing. Oh, okay, so what's going on there? It's got an outer, that's made out of aluminum there. Huh, interesting. So that appears to just be a retainer here. Okay, so it's just, yeah, here we go. So this is the, you know, when you're disassembling something like this is the thing you fear if you got to put it back together is loose balls. There we go. Okay. So if I'm right, these will be hard steel here. Yeah, these are hardened and ground here. You can see the grind marks on them still. So that's a really simple thrust bearing there. So 2 hard washers drop and 2 hard washers and an outer retainer with a bunch of small balls. And there's the lower washer there. Let's see if we can get that thing to move. Yeah. So not that you'd ever, well, I don't know, you might have to make one if you had something that had a peculiar space that you couldn't fit kind of a stock bearing into and you had to create a custom bearing, right? Let's see if we can lift that washer. Actually, all right, well, I gotta, it fits the ID pretty closely, so it's not wanting to come up. All right, well, let me collect these balls and that kind of sounds funny, doesn't it? Aluminum casting. Nice compression spring there. Okay. Boy, these guys spared no effort on this thing, did they? Okay. Well, does that come out? Nope. What's holding that on? So that's a cam there. So it's got a ramp, and that's what provides this tilt mechanism here. Remember I was saying the worm wants to be able to tilt so you can take out the plate. Wow, what's holding that? Interesting. It's a mystery. So my guess is it's held down by this plate here. Let's just oh boy, that's tight as the monkey's uncle there. All right, let's give it some persuasion here. That was easy. Yeah, there's rust on the ends of the screws there. So that got wet too. Okay, oh, here comes our worm assembly, or the screw. And then, oh wow, that's just sucked down to the plate. It's a nice ground finish, sitting on a ground finish. Well, that thing looks okay. See, they even shielded the thing with a tube there. Interesting. And you can see that this thing got seriously damp here or something at some point. So, all right, let's set that aside. Let's get that. That's just nice there. So yeah, there's a teeny bit of grease on that, so that sucked it right down to that. Okay, hey, now I can get at this screw. All that to get at that screw. Oh, that's tight. Okay. I don't want to twist off the tip of that. Look how thin it is, right? I mean, all right, well, let me see what else I got that'll get in there. So I stood it up so that I could push on the end of this a little bit. Okay, it's coming now. It's just a real close fit, and I suspect there's some, oh, there it goes. I can see that there's crud on it. Okay. Now that's that optical tube assembly there, but you see that it's pretty sick, so, I mean sick as in not well. And then that's the little viewport that light comes in, and there's a prism system in there, and you can see the end of that there. There's a prism there. That's pretty occluded. That's why you can't see anything in the actually we'll try taking that cover off and see what's underneath there. Okay, well, we're getting down to the brass tacks here, literally. We're taking this cover off now, and it's got these slotted screws here, and I tried one of them with this impact, and it just started to booger the screw pretty rapidly, and these are tighter than a monkey's uncle. Now I got one out, but I used this old school. I don't know if you guys have ever seen one of these. It's called a vessel impact driver. So it's basically got a cam system inside it that and people from the old motorcycle days with the Phillips screws in the side cases, everybody pretty much had one of these to get those screws out. And this bit fits real close, as I recall. It doesn't fit in that one. Maybe I need to clean that one there. Let's see here. Well, that slot's different, isn't it? Okay. Well, let's do the big one then. All right, this is a demo here. So what you do is you preload it in the direction that unwinds it, and then and what it does is it shocks it, and it has a cam action that twists it. Okay, like that. And then you can't use something like this on it at that point. Okay, yeah. Ooh, whew, boy, that's got a stink to it. That oil there. All right, let's do another one just for fun here. Okay, so insert, preload, and then whack, like that. Okay, all right, be right back. I figured out why there's two screws that are different, and I already cracked it loose. I'll show you what's going on here. So this is kind of odd. So it's got a bushing, right, that's threaded, and then, I don't know if, I'll shine a light down the hole there, and you can see that there is a fastener down there. Well, what that is it's actually a dowel pin that's holding all this together. And what this is I believe, is the extraction tool for that dowel pin. So theoretically, if I tighten this, believe it or not, then what that does is it's a taper pin. And I think I just undid the taper pin there. So if my theory's right, there'll be a pin on that. Yeah, okay. So you can see that pin's tapered. So that's just the extraction tool. So what they do is they put the pin in, and they drive the pin down, right? And then they just put this on as a decorative cap, right? But it's also sitting like that relative to the surface, so you can push on the surface, which extracts that pin a little bit. I hope that makes sense. So, all right, let's do this lower one here. And it cooperated. It's not too corroded, I guess. that one out. All right, well, it's loose anyway, so, oh, there it goes. All right, same thing there. Yeah, the taper pins are really good, actually, you know, at final assembly, because they assemble, you know, you drill a hole, then you ream it, you align everything, and then you drill a hole, then you taper ream it, and then when you drive a taper pin down into that hole, there's absolutely no play between any of the holes. So, so it takes out all looseness in the system. So it's actually a really effective way to control location of parts here. Now, I have no illusion that this plate's going to come off like super easy here. So I kind of surprised myself because I started tapping on it a little bit, and it was actually moving. So I figured let's turn the camera on just in case it comes out easy. So what this is here, this is an electrical interlock here, so that you can't turn the motor on when the thing's disengaged, the worm's disengaged. Yeah, look at all this crud in here. Yeah, this thing got seriously wet. So when this is in the unlock position, this makes contact, and it's, let's see, how does that work? So all the way in was tight, right? Oh yeah, which means that it opens the contact here. So, all right. Anyway, God, I know this thing weighs about 20 pounds here. Okay, and then we got another slit sleeve here, and now you can really kind of see the innards of this thing and see just how massive this casting is. I mean, this thing still weighs 100 pounds easy, right? And it's just massively built, right? It's quite the tank.